Hello students, welcome to Diksha Karnataka YouTube channel. Abhyas KCET 2024 mock test 8 has been released, right? So in this video, I'm going to discuss the solution of mock test 8, okay, part 2, question number 151 to 180. So if you haven't downloaded the question paper, please join the WhatsApp channel using the link which is given in the description box, okay? In there you will get the question papers of mock tests. Yeah, so let us start. Question number 151. When the velocity of an electron increases, its de Broglie wavelength. Okay, so here when the velocity of the electron increases, its de Broglie wavelength. We know the expression of the de Broglie wavelength, right? De Broglie wavelength, lambda equal to h divided by p. What is h? H is Planck's constant, p is momentum of the particle, right? In this case, particle is electron. So de Broglie wavelength lambda equal to h divided by m into v, right? When the velocity of the electron increases, its de Broglie wavelength decreases. Okay, so the correct option is B. Yeah, next question. Question number 152. Magnetic lines of force due to a bar magnet do not intersect because a point always has a single net magnetic field, right? A point always has a single net magnetic field. By here, when magnetic field intersects, okay, intersect, here this is the point of intersect. So at this point, magnetic needle will show different direction, right? It is not possible, it is impossible, right? So at a point always has a single net magnetic field, okay? So the correct option is A. Yeah, next question, question number 153. In an experiment, it is found that the magnetic susceptibility of given substance is much more greater than 1. Here, magnetic susceptibility is much more greater than 1 for a given substance. The possible substance is, here the possible substance is ferromagnet, okay? Ferromagnetic. Okay, ferromagnetic. So the correct option is C. For ferromagnet, magnetic susceptibility is much more greater than 1. Okay. Question number 154. The magnetic field dB vector, okay, dB vector, due to a small current element dl vector, here this is dl vector, at a distance r vector and element carrying current I is. So they are asking, okay, they are asking the Biot-Savart's law, right? So what is the Biot-Savart's law? Biot-Savart's law, dB vector is equal to mu naught divided by 4 pi into I into dl vector cross r vector divided by r cube, right? So this is the Biot-Savart's law, right? Isn't it? So this is the current carrying wire, okay? This is the point P, we are finding the magnetic field, okay? So position vector is r vector, right? This is the angle theta. Here angle theta is between current element and r vector, okay? So at point P, the magnetic field is dB vector is equal to mu naught divided by 4 pi into I into dl vector cross r vector divided by r cube, okay? So the correct option is D, okay? dB vector equal to mu naught I divided by 4 pi into dl vector cross r vector divided by r cube. Yeah. Next question, question number 155. If the current sensitivity of a galvanometer is doubled, then voltage sensitivity will be. Okay, we know that current sensitivity Is is equal to theta, that is deflection in the galvanometer, divided by current I, right? Now, which is equal to NAB divided by C, right? So what is N? N is number of turns in the coil, A is area of the coil, right? B is magnetic field, right? C is restoring couple, okay? Restoring couple per unit twist, okay? Restoring couple per unit twist, okay? Restoring couple per unit twist. So here voltage sensitivity Vs is equal to Is divided by R, right? Is divided by R, isn't it? So here Is is NAB by C, right? So Vs is equal to Is, that is NAB divided by C into 1 by R. Okay, yeah. Now the current sensitivity doubled, right? Here the current sensitivity doubled. We need to find the voltage sensitivity. Yeah, if current sensitivity doubled, then the number of turns will be more, right? We need more number of turns, right, to get the more current sensitivity, right? If current sensitivity doubled, then n has to be doubled, right? The value of n has to be doubled. So if the number of turns increases, then the number of turns increases, then the length will also be increases, right? Length of the wire will also be increases, right? We need more wire to increase the number of length, right? So length will also be increases. If length increases, resistance will also be increases, right? Isn't it? Resistance will also be increases. So if current sensitivity doubled, then number of turns will also be doubled, right? Number of turns will also be doubled. If number of turns doubled, then the length will also be doubled. If length is doubled, then resistance will also be doubled, right? So R dash equal to 2R, right? Now Vs, the current sensitivity, new voltage sensitivity, Vs dash is equal to Is dash divided by R dash. What is Is dash? Is dash is 2Is, okay? Vs dash is equal to 2Is divided by 2R. Your 2 will get cancelled. So voltage sensitivity will be same, okay? So voltage sensitivity will be same, that is remains unchanged. So the correct option is C. Okay, yeah. Next question. Question number 156. A long straight wire carries a current of 75 ampere. Then the magnitude of the field B at 0.3 centimeter away from the wire is. Okay, so this is the current carrying long wire. Okay, current is 75 ampere. Okay, so we need to find the magnetic field at a point P, okay, which is 3 centimeter away from the wire. Okay, 3 centimeter away from the wire. So we know that magnetic field due to the current carrying long wire is B, which is equal to mu naught I divided by 2 pi r, right? Mu naught I by 2 pi r. Okay, so this is the magnetic field at point P due to current carrying straight wire. Okay, so we know the value of mu naught I and r, right? Substitute. Okay, before that, how we got this formula? We got this formula using the Biot-Savart law or Ampere circuit law. Okay, now B is equal to mu naught, that is 4 pi into 10 to the power minus 7 into I is 75 ampere divided by 2 pi into r. R is 3 centimeter, that is 3 into 10 to the power minus 2 meter. Now solve this, you will get P equal to 5 into 10 to the power minus 4 Tesla. Okay, so the correct option is B. I think in your question paper they have given wrong answers. Okay, so the wrong answer and wrong question. Okay, okay, question is correct, but they have given wrong options. Okay, so the correct option is B. Yeah, next question. Question number 157. An electron is moving in a circle at a speed of 3.2 into 10 to the power 7 meter per second in a magnetic field of 5 into 10 to the power minus 4 Tesla. Okay, so V is the velocity of the electron, B is the magnetic field, okay, perpendicular to it. That is, the motion of the electron is perpendicular to the magnetic field. What is the frequency of this electron? Okay, so frequency of the electron, F equal to 1 divided by T, right? So what is T? T is time period, right? So what is the meaning of time period? Time period is time taken by the electron to complete one circle, right? Yeah. Now time taken by the electron to complete one circle, T is equal to distance traveled by the electron, that is circumference of the circle, divided by velocity of the electron, right? Velocity of the electron is V. Now T is equal to 2 pi r divided by V, right? So we don't know the value of r, right? That is the radius of the circle. We know that the radius of the circle or circular path taken by the electron is m into v divided by q into b, right? M is mass of the electron, v is velocity of the electron, q is charge of the electron, b is magnetic field, right? Now here T is equal to 2 pi into R, that is mv divided by qb whole divided by v. Here v will get cancelled, right? Now time period T is equal to 2 pi m divided by q into b. Okay, we need to find the frequency, that is 1 by t. 1 by t is q into b divided by 2 pi m. Okay, q into b divided by 2 pi m. Now f is equal to, q is 1.6 into 10 to the power minus 19 into b is 5 into 10 to the power minus 4 Tesla divided by 10 to the power minus 4 Tesla is 1 Gauss, divided by 2 pi into m. M is mass of the electron, 9.1 into 10 to the power minus 31 kg. Okay, now f is equal to, here 2 pi is 6.28, right? 6.28. So here f is equal to 1.4 into 10 to the power, here 10 to the power minus 19 into 10 to the power minus 4 is 10 to the power minus 23, right? So this will be 10 to the power minus 30, right? 10 to the power minus 30. Okay, 6.28 into 9.1, so it will be in tens, right? So 10 to the power minus 30. So 10 to the power minus 23 divided by 10 to the power minus 30 is 10 to the power 7, right? 10 to the power 7. So here 1.6 into 5, right? So it is 8, right? 8 divided by, it is in 10, so you will get 0 point something, right? 0.14 into 10 to the power 7, I guess, right? So 10 to the power 7, right? So 1.4 into 10 to the power 6 hertz. Okay, 1.4 into 10 to the power 6 hertz. So the correct option is B. Correct option is C. Okay. Yeah. Next question. Question number 158. The Rutherford alpha particle experiment shows that most of the alpha particle pass through almost unscattered, while some are scattered through large angles. What information does it give about structure of the atom? Okay, let's look at each option. Option A, atom is hollow. This is correct, right? Isn't it? So the alpha particle pass through almost unscattered, right? That is, it says that the atom has empty space, right? More empty space, isn't it? Not more empty space. Atom is hollow, right? Isn't it? So option A is correct, right? Option B, the whole mass of the atom is concentrated in a small center called nucleus. Correct, right? From the gold foil experiment only, Rutherford's gold foil experiment only, here we got to know that here atom is concentrated, it's a small center called nucleus. Okay, isn't it? So why? Because some of the alpha particle got scattered, right? Yeah, so option B is correct. Option C, that is some of the alpha particle got deviated. Okay, so option C, nucleus is positively charged. Correct, right? Here some of the alpha particle scattered by 180 degree, right? 180 degree. So this indicates that here this nucleus is positively charged. How? Because there is a force of repulsion between the like charges, right? Isn't it? When the force of repulsion occurs, when there is a like charges, right? Alpha particle is a positive charge. So when it's scattered by 180 degree, it means nucleus, this gold foil nucleus is also positively charged, right? So option C is also correct. Option D, all of the above. Yeah, So the correct option is D, right? Correct option is D. Okay. Correct option is D. Yeah. Next question. Question number 159. The de Broglie wavelength of an electron in the first Bohr orbit is. Okay. Yeah. So here we know that electrons, angular momentum of the electron, okay, angular momentum of the electron is integral multiple of h by 2 pi, right? From the Bohr atomic model, okay. So angular momentum of the electron mv/rn is equal to nh divided by 2 pi, right? nh divided by 2 pi. Okay. So mv is momentum, right? Momentum of the electron. So P is momentum of the electron. P into Rn is equal to nh divided by 2 pi, right? P into Rn equal to nh by 2 pi. So P is momentum of the electron, right? We know that de Broglie wavelength lambda is equal to h divided by P. P is momentum of the electron, lambda is de Broglie wavelength of the electron. So P equal to h divided by lambda, right? P equal to h by lambda. So now substitute here this P to this equation. H divided by lambda into Rn is equal to nh divided by 2 pi. Here h will get cancelled, okay? So lambda is equal to 2 pi Rn divided by n, okay? Rn is radius of the nth orbit, okay, or orbit n. Here they are asking de Broglie wavelength of an electron in the first Bohr orbit, that is n equal to 1, right? So lambda is equal to 2 pi r1 or 2 pi r divided by 1. So lambda equal to 2 pi r, okay, lambda equal to 2 pi r. So option A says equal to 1/4 of the circumference of the first orbit. Wrong, right? Wrong. It is circumference of the orbit only, right? Yeah. Equal to half the circumference of the first orbit. Wrong. So, the third one equal to twice the circumference of the first orbit. Wrong, right? B and C are wrong. Option D equal to the circumference of the first orbit. Correct. Equal to the circumference of the first orbit. D. So de Broglie wavelength of the electron in the first Bohr orbit is equal to circumference of the first orbit. Okay. Yeah. Next question. Question number 160. The binding energy per nucleon of deuterium and helium nuclei are 1.1 mega electron volt and 7 mega electron volt respectively. When two deuterium nuclei fuse to form a helium nucleus, the energy released in the fusion is. Okay, so let us write the equation. Two deuterium combines to form helium, right? Isn't it? So then energy is also released, right? Delta E, isn't it? Okay, so how to find delta E? Let us find the binding energy of the deuterium and helium. Okay, then take the difference, that is equal to delta E, that is energy released, right? Okay, so what is the binding energy of the helium? Here binding energy of the helium, binding energy per nucleon of the helium is given, right? So binding energy of the helium is equal to 4, that is nucleon, number of nucleons 4 into, okay, nucleon into binding energy per nucleon of the helium, that is 7, which is equal to 28 mega electron volt. 7 mega electron volt. 7 mega electron into 4 is 28 mega electron volt. Let us find binding energy per nucleon for deuterium atom. So binding energy per nucleon for deuterium, right? So which is equal to 2 into 1.1, which is equal to 2.2 mega electron volt, right? So how many deuterium nuclei is there? 2, right? So 2 into 2.2 is equal to 4.4 mega electron volt, right? 4.4 mega electron volt. So binding energy of the two deuterium nuclei is 4.4 mega electron volt. We need to find energy released, right? Energy released is equal to, here binding energy of the helium atom, that is 28 mega electron volt, minus binding energy of the two deuterium atom, right? So that will be 4.4 mega electron volt. Now solve this, you will get delta E is equal to 23.6 mega electron volt. So the correct option is A. Okay. Yeah. Next question. Question number 161. When the number of nucleons in the nuclei increases, the binding energy per nucleon. Okay. We know the graph, right? Average binding energy per nucleon versus mass number. Mass number, right? This is the graph, right? Something like this, right? So average binding energy per nucleon, okay, here it increases when the mass number increases, right? Isn't it? First it increases when the mass number increases, right? Then it decreases, right? With the increase in mass number, right? First binding energy per nucleon, average binding energy per nucleon increases, right? When the mass number increases, right? So then average binding energy per nucleon, decreases as mass number increases, right? So option A says increase continuously with mass number, wrong. Option D, decrease continuously with mass number, wrong. Remains constant with mass number, wrong. Option D says first increases, correct, and then decreases with the increase of mass number, correct. So option D is the correct answer. Okay, yeah. Question number 162. An electromagnet has stored 648 joule of magnetic energy, that is half Li square is equal to 648 joule, right? Half Li square is magnetic energy. When a current of 9 ampere exists in its coils, what average EMF is induced if the current reduced to 0 in 0.45 second? Okay, so we know the relationship between L, I, okay, and phi, magnetic flux, right? Li equal to N into phi. This is the relationship between self-inductance I, that is current, and magnetic flux, right? Now differentiate both sides with respect to T. Now L into di divided by dt is equal to N into d phi by dt, right? So what is N into d phi by dt? Induced EMF, right? Isn't it? Induced EMF, that is minus E. Actually induced EMF E equal to minus N into d phi by dt, right? So d phi by N into d phi by dt is minus E, right? So now I can write this equation as E equal to minus L into di by dt, minus L into di by dt, right? So we have to find average EMF induced if the current reduced to 0, right? So now average induced EMF E equal to minus L into delta I by delta T, okay, delta I by delta T. Now E is equal to minus L into delta I, that is final current, minus initial current, divided by delta T. Delta T is 0.45 second, right? 0.45 second. Now E is equal to L. L we need to find, right? How we can find L? They have given energy, right? So we can easily find L, right? I is given, right? 9 ampere. Now L is equal to 2 into 648 divided by I square, right? I square is here 9 square, right? 9 squared. So now E equal to minus L. L is 2 into 648 divided by 9 squared into delta I. Delta I is 0 minus 9, right? 0 minus 9. divided by delta t. Delta t is 0.45, right? So 0.45, I can write 0.45 as 4.5 into 10 to the power minus 1, right? That is 9 by 2 into 10 to the power minus 1, right? So minus into minus plus, 0 minus 9 is minus 9, minus into minus plus. So E equal to here 2 into 2, 4, 4 into 6, 48 into 9 divided by 2 into 640 into 8, 4 into 648 into 9 into 1 by 10 to the power minus 1 is 10, right? So into 10 divided by 9 cube, right? So here 9 and 9 will get cancelled, right? So now E is equal to here 4 into here 6.48 into 10 to the power 3 divided by 9 squared, that is 81, right? 81 is 8.1 into 10 to the power 10 to the power 1 or 10, right? So this is approximately equal to 2, right? So this will be 3, okay? Here this will be 2, 4, okay? So here E is equal to, here I am doing rough calculation, okay? Here we are getting 324, but in option A they have given 320, right? So induced EMF E is equal to 320 volt, okay? This is the rough calculation. So option A is the correct answer, okay? Next question, question number 163. When a wire loop is rotated in a magnetic field, the direction of the induced EMF changes in every, okay? Here we know that the current induced EMF E equal to d phi by dt, right? Induced EMF E equal to d phi by dt. So what is phi? Phi is magnetic flux, right? That is BA cos theta, right? BA cos theta. What is theta? In this case theta is A and B, right? It is rotating, right? So theta is considered as angular displacement. Angular displacement is BA. Here angular displacement is cos omega t. Now differentiate phi with respect to t. Now E is equal to minus B A omega. So this is minus d phi by dt. Okay, minus into minus plus. So plus B A omega sine omega t, right? Plus B A omega sine omega t. Sine omega t, right? So here the induced EMF varies sinusoidally, right? It varies sinusoidally. So when the wire loop is rotated in a magnetic field, the direction of the induced EMF changes every half revolution, right? Every half revolution, the direction of the magnetic field, induced EMF changes, right? At this point, induced EMF changes. Again, at this point, induced EMF changes. So what is the point? This point indicates half revolution, right? So at a half revolution, its induced EMF changes, right? So the correct option is B. Okay. Question number 164. A circular copper disc 10 centimeter in diameter, so the radius will be 5 centimeter, rotates at 1800 revolution per minute, that is omega equal to 1800 revolution per minute, that is 2 pi by 60. Okay, about an axis through its center and right angles to disc. Here this is the disc. Okay, the axis passing through the center, about an axis passing through its center and right angles to the disc, right? A uniform magnetic field of induction B equal to 1 Weber per meter square is perpendicular to the disc. What potential difference is developed between the axis of the disc and the rim? Here this is the disc, right? So when it rotates, okay, so there will be a induced EMF, or the potential will develop at the axis of the ring and axis of the disc and rim of the disc. Okay, so we need to find the potential difference. Okay, in the magnetic field, when it rotates in the magnetic field, there will be a potential at the axis of the disc and rim of the disc. We need to find potential difference. Now the potential difference is E, which is equal to half B L square into omega, right? So how we got this formula? We got this formula okay, by using motional EMF. Go to the NCERT and go through just go through the derivation. Okay, now E is equal to half B. B is 1 Weber per meter square. L square is 5 centimeter square, that is 25 into 10 to the power minus 4 into omega. Omega is here 30 into 2 pi, 60 pi, right? So this will be 30, right? Now solve this, you will get E equal to 0.23 volt. Okay, so the correct option is B. Yeah, next question, question number 165. The relation between an AC voltage source and time in units is V equal to 120 sine of 100 pi t into cos of 100 pi t volt. The value of peak voltage and frequency will be respectively. Okay, so here this is the given voltage equation, right? So what is the general equation? General equation is V equal to V naught into sine of omega t, right? So we need to write the given equation in the form of this equation, right? So now observe the given equation. So this is in the form of 2 sine omega t into cos omega t, right? Now I can write this form here, this equation in the form of 2 sine theta into cos theta, not omega t, 2 sine theta into cos theta, right? Isn't it? We know that sine 2 theta is equal to 2 sine theta into cos theta. 2 sine theta into cos theta, right? Now sine 2 is 2 into theta. Theta is here 100 pi. So 200 pi equal to 2 into, here this is in the form of 2 sine theta is cos theta, right? So 2 into 60 into sine of 100 pi t into cos of 100 pi t, cos of 100 pi t, right? So now what is the peak voltage? Here the peak voltage is 60 volt, right? Peak voltage is 60 volt, right? So what is the, here this is 200 pi t, okay? So what is the value of frequency? Here omega equal to 200 pi, right? 200 pi. So f equal to 100 hertz. Omega is 2 pi f, so f equal to 100 hertz. So peak voltage is 60 volt, frequency is 100 hertz. So option D is the correct answer. Okay. Question number 166. A phase difference between voltage and current in capacitor in an AC circuit is, the direct question, right? It is pi by 2 because the voltage across the capacitor lags behind the current, right? So option B is the correct answer, pi by 2. Okay. Next, okay, if you want to draw me a graph here, VC and I into R, right? 90 degree minus pi by 2. Yeah. Next question, question number 167. At resonance frequency, the impedance in series LCR circuit is, okay, at the resonance, the impedance in series LCR circuit is minimum, right? Minimum. Why it is minimum? At resonance, inductive reactance is equal to capacitive reactance, right? Impedance Z is equal to R square plus XL minus XC whole square, right? XL minus XC is 0, so Z equal to R, right? So impedance is minimum. So option B is the correct answer. Okay. Next question, question number 168. In a transformer, the transformation ratio is 0.3, that is Ns by Np. The number of turns in the secondary coil to the number of turns in the primary coil is 0.3. If 220 volt AC is fed to the primary, that is Vp is equal to 220 volt, then voltage across the secondary is, that is Vs. We need to find Vs, right? We know that Vs divided by Vp is equal to Ns by Np, right? Vp is given, we need to find Vs. Ns and Np is also given. Okay, sorry, Ns by Np is also given, that is 0.3. So Vs equal to Vp into Ns by Np is 0.3. So Vs is equal to Vp. Vp is 220 volt, into 0.3. Vs is equal to 66 volt. So the correct option is D. Okay. Yeah. Next question. Question number 169. In the half wave rectifier circuit operating from 50 hertz main frequency, the fundamental frequency in the ripple would be, the fundamental frequency in the ripple would be same, right? 50 hertz only. Why? Because output from the half wave rectifier is, the frequency of the output from the half wave rectifier is half. Okay, so here we get the output only one half of the input AC source, right? Isn't it? We get the output from the half wave rectifier, okay, is one half of the input, right? One half of the input, isn't it? One half of the input, right? So therefore the fundamental frequency in the ripple would be same, 50 hertz only. Okay, so option B is the correct answer. Okay, next question. Question number 170. Question number 170. Which of the following statements is incorrect for the depletion region of a diode? Okay, let us draw the depletion region. Okay, so this is P side and N side. Okay, so this junction or this region is depletion region. Okay, so here there are negative charges, that is electrons. Okay, here P side is positively charged, that is holes. Okay, here holes. Okay, in this side. Okay, and then here negative charges, that is electrons. Okay, electrons. So why it takes place here? This is depletion region. Okay, DR. So why it takes place? Because here there is a positive charges, right? Holes. Here N side carries more electrons, right? Because of the Coulomb's attraction, these electrons moves towards this region. Okay, that is the P region. Okay, so, and it recombines with the holes. Okay, recombines with the holes. That's why in this side the negative charges accumulates, and this side holes will accumulate. Okay, so this is the depletion region. So there the mobile charges exist. No, mobile charges does not exist, right, in the depletion region. Okay, so option A is wrong. So we have to find the correct here incorrect statement, right? So option A is correct. Okay, statement in the option A is wrong. Option B says equal number of holes and equal number of electron exist, making the region neutral. Correct. So this region is neutral and number of electrons is equal to number of holes. Okay, recombination of the holes and electrons has taken place. Yeah, correct, right? Recombination of the holes and electron taken place, right? In depletion region electric field exists. This is also correct, right? Electric field exists in the depletion region. Okay, because there is positive charges and negative charge, right? Yeah, so option A is the correct answer. Next question. Question number 171. The VI characteristic of a silicon diode is shown in figure. The resistance of the diode at ID equal to 15 milliampere. Okay, so we need to find the resistance of the diode at ID 15 milliampere, right? Okay, so the resistance of the diode R equal to delta V divided by delta I, right? Delta V by delta I. This is the resistance of the diode. Now R is equal to delta V is Vf, okay, or V2, okay, let's say V2 minus V1, okay, V2 minus V1 divided by delta I. Delta I is here I2 minus I1, I2 minus I1, right? I2 minus I1. Now R is equal to V2. So what is the value of V2? V2 is 0.8, right? Minus 0.7. Okay, V1 is 0.7 divided by I2. I2 is 20, I1 is 10. So 20 minus 10. So R is equal to, here this will be 0.1 divided by 10, right? 0.1 by 10, isn't it? So R equal to 0.8 minus 0.7, that is 0.1 divided by 20 minus 10, right? 20 minus 10. So it is in milliampere, right? So 20 minus 10 into 10 to the power minus 3. So this will be 10 to the power minus 2, right? So 1 by 10 to the power minus 2 is 10 to the power 2. 0.1 into 10 to the power 2 is 10, right? 10 to the power 1, that is 10. So option B is the correct answer. 10 ohm resistance of the diode. Yeah, question number 172. On doping germanium with donor atoms of density 10 to the power 17 centimeter cube, its conductivity in ohm, okay, its conductivity in ohm per centimeter will be, okay. So the conductivity sigma is equal to density of the donor atoms, okay. So that is Ni into E into mobility of the electron mu E. Now sigma is equal to Ni is 10 to the power 17 centimeter cube per centimeter cube, right? Per centimeter cube into what is the value of E? E is 1.6 into 10 to the power 1.6 into 10 to the power minus 19 coulomb, right? Into mu E. Mu E is 3800 into 3800 centimeter square per voltage second, right? Now here centimeter square, here centimeter cube will get cancelled, right? So this will be 1 by centimeter or per centimeter, isn't it? Now sigma is equal to here 10 to the power 17 into 10 to the power minus 19, that is 10 to the power minus 2, right? So 10 to the power minus 2 into 10 to the power 3 is 10, right? So 10 into 1.6 into 3.8, right? So now sigma is equal to, what is the value of 1.6 into 1.8? The value of 1.6 into 1.8 is 6.08, right? 6.08. So 6.08 into 10. So the value of sigma equal to 60.8. What is the SI unit? SI unit is ohm per centimeter. So the correct option is B. Okay. Yeah, next question. Question number 173. The ratio of electron and hole current in semiconductor is 7 by 4 and the ratio of drift velocity of electrons and holes is 5 by 4. Then the ratio of the concentration of electrons and holes will be, we know that the current I is equal to, okay, drift velocity Vd is equal to the current I divided by N into E into A, right? N into E into A. Okay, here they have given the ratio of electrons and hole current in a semiconductor is 7 by 4, right? The ratio of electron and hole current in a semiconductor is 7 divided by 4, right? And the ratio of drift velocity of electrons and holes is 5 by 4, right? 5 by 4. Now we need to find the ratio of the concentration of the electrons and holes, that is Ne by NH. Okay, Ne by NH. Here VDH, sorry, not VDE. Okay, now here VDE divided by VDH is equal to here IE divided by NE, okay, into E into A divided by IH divided by NH into E into A. The charge of the hole and electron is same, right? And area of cross section is also same. So 1 by EA, 1 by EA will get cancelled, right? So VD E divided by VDH is equal to here NH divided by NE into NH divided by NE into IE divided by IH. Okay, IE by IH. So we need to find NE by NH, right? NE by NH. So NE by NH, here I am writing, okay, NE by NH. NE by NH is equal to, here, VDH divided by VDE into VDH divided by VDE into IE divided by IH. Okay, IE by IH. Now, what is VDH by VDE? Here VDH by VDE is 4 by 5, right? So 4 divided by 5 into, what is IE by IH? IE by IH is 7 by 4. 7 by 4. So 4 will get cancelled. Finally, NE by NH is equal to 7 divided by 5. So the correct option is B. Okay. Next question. Question number 174. The image found by a concave mirror is. So it's certainly real if the object is virtual. Okay. So let's see how. So what is the mirror formula? 1 by V plus 1 by U equal to 1 by F, right? So 1 by V is equal to 1 by F minus 1 by U. Okay. So for real image, object distance is negative, right? Isn't it? So if object distance is negative, we will get real image, right? So this is the concave mirror. Okay. If object distance is negative, okay, here this is the object. If object distance is negative, anyway we will get real image, right? So when the object is virtual, right? When the object is virtual, that is U equal to positive, right? U is greater than 0, right? When the object is positive, here we will get real image, right? Isn't it? That is V is negative, right? That is image will lies in front of the concave mirror, right? So certainly the image is real, okay? Certainly image is real and object is virtual. Object is virtual. Okay. So from this we can conclude that concave mirror produces real image, okay? Certainly produces real image if the object is virtual. Okay. So the correct option is C. Next question, question number 175. If a ray of light traveling in a transparent medium of refractive index mu falls on a surface separating the medium from at an angle of incidence 45 degree, for which of the following value of mu the ray can undergo total internal reflection? Okay, so what is the condition for total internal reflection? The condition for total internal reflection, that is sin I, must be greater than sin C, right? Sin I must be greater than sin C. Sin C. Let us find this value of sin C. Okay. So, okay, let us find the value of mu. Okay. From using sin C. Here C is critical angle. Okay. C is critical angle. So, let us find the value of mu using sin C. C is critical angle, that is 45 degree. So, sin 45 degree is equal to 1 divided by mu. We know that sin C is equal to 1 divided by mu, right? Isn't it? So sin 45 degree is 1 by mu. So mu equal to root 2. Okay, mu equal to root 2. So we need to find the value of mu so that the ray can undergo total internal reflection. Okay, that is here sin I. Okay, that is mu equal to here mu equal to root 2, right? That is 1.414. Okay, if ray can undergo total internal reflection, then the value of mu has to be greater than 1.414, right? See, just look at the option in options A, C and okay, A, B and D. Okay, A, B and D. Here refractive index is 1.3, 1.4 and 1.25, which is lesser than 1.414, right? So the ray do not undergo total internal reflection, right? So when the refractive index is 1.5, it undergoes total internal reflection when the angle of incidence is 45 degree. Okay, so the correct option is C. Okay, next question, question number 176. The angle of minimum deviation for prism angle pi by 3 is pi by 6, A equal to pi by 3, delta m equal to pi by 6. If the velocity of the light in vacuum is 3 into 10 to the power 8 meter per second, then the velocity of the light in material of the prism. Okay, so let us find the refractive index of the prism. Okay, so from that we can easily find the velocity of the light in material of the prism, right? Here refractive index of the prism mu equal to C divided by V, right? V is velocity of the light in material of the prism, right? Let us find the mu. We know that refractive index of the prism mu equal to sine of A plus delta m divided by 2 whole divided by sine of A by 2. So what is A? A is angle of prism, delta m is angle of minimum deviation, okay, mu is refractive index of the prism. Yeah. So what is the value of A? A is pi by 3, delta m is pi by 6, right? So now substitute the values, okay. Here mu equal to sine of pi by 3 plus pi by 6 whole divided by 2 into sine of A by 2, right? That is pi by 6. So what is pi by 3 plus pi by 6? Take pi by 3 as common. So this will be 1 plus 1 by 2. 1 plus 1 by 2 is 3 by 2. Okay. So 3 by 2 into pi by 6, right? 3 by 2 into pi by 6 is pi by 4, right? Now mu equal to sine of here pi by 3 into 3 by 2, okay, whole divided by 2, okay, whole divided by 2, okay. So this is into 3 by 2, right? So whole divided by 2 divided by sine of pi by 6, that is 1 by 2, okay. So this is pi by 4, right? Mu equal to sine of pi by 4, that is 1 by root 2, right? 1 by root 2. So 1 by root 2 by 1 by 2, that is root 2. Mu equal to root 2. Root 2 is 1.414, right? We got the value of mu. We need to find the value of V. Now V equal to C divided by mu, right? So V equal to C is 3 into 10 to the power 8 divided by 1.414 into 1.414, okay, 1.414. Now V is equal to, if you solve this, you will get 2.12 into 10 to the power 8 meter per second. So the correct option is C. Okay, yeah. Next question, question number 177. A plane wave passes through a convex lens. The geometrical shape of the wave front that emerges is, okay. So let us draw the wave front only, okay. See, we know that convex lens is a converging lens, right? Convex lens is a converging lens. This is the wavefront, right? This is the wavefront, and this wavefront is converging spherical, right? Spherical wavefront, and it is converging, right? So converging spherical. So the correct option is C. Okay, correct option is C. Yeah. Next question. Okay. Next question, question number 178. In Young's double slit experiment, the ratio of intensity of the maxima and minima in the interference experiment is 25 by 9. That is, I max by I minima is 25 by 9. Okay. The ratio of the width of the two slits, that is amplitude, right? Isn't it? So we know that I max by I minima is equal to, I max by I minima is equal to, here A2 plus A1 divided by A2 minus A1 whole squared, right, which is equal to 25 by 9. 25 by 9. So A2 divided by A1 plus 1 divided by A2 by A1 minus 1 is equal to 5 divided by 3, right? 5 by 3, isn't it? So then 3A2 divided by A1 plus 3 equal to 5A2 divided by A1 minus 5, right? Now here 5A2 by A1 minus 3A2 by A1 is equal to, here 5 plus 3 is 8, right? Now this is equal to 2A2 by A1, okay? So 2A2 divided by A1 is equal to 8. Now A2 divided by A1, that is the ratio of the widths of the two slits, is equal to 4 or 4:1, okay? A2 is to A1 is equal to 4:1. So the correct option is B, okay? Next question, question number 179. Two nickels are oriented with their principal planes making an angle of 60 degree. Then the percentage of incident unpolarized light which passes through the system. Okay, so two nickels are oriented with their principal planes making an angle 60 degree. Principal planes making an angle 60 degree, right? Sorry, yeah, two nickels, right? Okay, only two nickels making an angle 60 degree, right? So we need to find the percentage of incident unpolarized light which passes through the system. Here I0 is the intensity of the incident light wave, right? When it passes through the first nickels, okay, or first polarizer, okay, what happens? Intensity reduces to half, right? Intensity reduces to half. Then this intensity passes through this polarizer. The new intensity I dash is equal to I0 by 2 into cos square theta, Malus law, right? Theta is 60 degree, right? Now I0 divided by 2 into cos square 60 degree. Cos square 60 degree is 1 by cos 60 degree is 1 by 2. So cos square 60 degree is 1 by 4. So I0 divided by 8, right? I0 divided by 8. So in percentage, here we need to find the percentage, right? So into 100%. So this will be 12.5. So the correct option is C. Okay. Next question. Question number 180. A simple telescope consisting of an objective of focal length 60 centimeter, that is FO is equal to 60 centimeter, and single eye lens of focal length 5 centimeter, FE is equal to 5 centimeter, focused on a distant object in such a way that parallel rays emerge from the eye lens. If the object subtends an angle of 2 degree at the objective lens, the angular width of the image is, okay, we know that magnification of the telescope, okay, simple telescope, M equal to angular width beta divided by angle subtended by the object, okay, or objective, that is alpha, is equal to FO, that is focal length of the objective lens divided by focal length of the eyepiece. Okay, now here beta we need to find, okay, which is equal to alpha into FO by FE. So beta is equal to alpha is 2 degree, FO is 60 centimeter, okay, FE is 5 centimeter. So this is 12. So beta is equal to 24 degree. Beta is equal to 24 degree. Okay, this is the angular width of the image. Thank you so much. So if you love this video, please like and share. Okay, so if you want to watch more such videos, please subscribe. Thank you.